In the previous video, we looked at the similarities and differences between the copy and the instance node. And in this video, we're going to dive deeper into the copy node. So we still have the same thing. We have one dir instantiated on one plane. And let's say we want to have different geometries on every point. That's where the copy node can be useful. What it does is it can reevaluate the graph on the left input for each point differently. So let's say we want to import a different geometry. So in that case, we can import a wolf. We're going to add this one. So I'm still giving it the same transform to make sure it is oriented towards the z-axis, like this, just like the deer is. And now I can simply switch between each of them. So I can plug one or the other. But I can also use a switch node, which will allow me not to have to plug and replug things. I can simply change this parameter. And now I want to have a way to have this change for every single point. So I can toggle the use copy expression on, and I can use the copy expression. So I can simply point it to the copy node and give it a default value of 0. So in that case, we get an error. And if we look at it, we say no input 3. So what that means is that these get evaluated for every point. It will return 0 for the first point, 1 for the second, 2 for the third, and so on. So when it evaluates to 2 or 3, there is no input here. So it cannot return any value. So we need to give it modulo 2, so we only have the values 0 or 1. And it will simply alternate bit from this to this. So now if I simply change the plane size and I increase the number of points, I will get different pattern, and each point will return a different geometry. This will keep being evaluated as we change the input. So, and we don't have to use this only once, we can use it several times. So let's say we want to have, for some of the geometries, we want to have a box instead of a wolf or a deer. And in that case, by adding just a box, it created a box around each of them. But I want to do it just for some of them. So let's say I'm going to simply duplicate this. And if I just reuse it like that, it will simply use it for only the wolf, but I want to have it for either the wolves or the deers. So I'm simply going to change this expression. I mean, instead of just using a copy, I'm going to use a random of this. And I'm going to say when this is superior to 0.25, let's say. And I'm going to add a seed to this. So now you can see that sometimes we have a box, sometimes a deer, and sometimes a wolf. And we can also chain the copy node. We don't need to simply use only one. So let's create another one. And now we can have two copies, let's say, but now both copies are going to be on top of each other, so not very visible. So let's try and simply offset one on top of the other. So we're going to use a transform node, and I'm going to transform it like that, but I want this translate to be different for each. So again, I'm going to use the same copy expression, copy. In that case, I give it the path to the new node, which is copy2, default value of 0, and here you go, we have both of them on top of each other, but they kind of look the same. So let's try to have a different pattern of boxes. So I'm going to use this same expression, and I'm going to put it in this second switch instead of the seed. So now we're going to see that the boxes are going to move. So now we have a wolf when we have a box, and each position is slightly different. And we can, in the first one, we could only apply the copy expression on the left. But then on that one, the left graph is all this, it includes this plane. So we can even put this expression that we have here on the plane itself to vary the number of points. So let's try and simply do that. And now we're going to see that the second plane is going to be bigger. We have more points here than here. So let's make it a little clearer like this, by increasing this. So we can see we can keep adding, so, and we can just by changing one parameter, we can have another layer and even more geometries. So that's a way to to create unique variations and keep reevaluating the whole graph to suit your needs. And because the geometry is still editable, now we start to have many points, so things will start to get slow, and that's where optimization might be needed. But for the sake of the example, we can simply use a noise and keep deforming the geometry like this. So as you can see, the copy node is very flexible and can allow you to do very rich graphs and operations that you can combine many operations thanks to it.